This is my report which investigates Newton's second law of motion, which can be arranged as V final is equal to V initial plus the net force over mass times delta t to predict motion future. We will be observing the motion of a ball in constant velocity and comparing it to the motion predicted by a computer model. The investigation used the following. In the observation experiment, a video recording was made of a ball rolling across a board in a straight line path perpendicular to the camera view, and a ruler was used to scale the images. Upon completion, the video was loaded into Tracker for analysis. Here, the centre of the ball's mass is marked for each video frame as the ball moves along the board. The data is presented in graphical form here and tabular form here. If we now press the play button, we generate this data as the ball progresses through the frames of interest. Here we see the resultant graph and the table of data showing the ball's position versus time. For the motion prediction model, we will need some initial setup data. We take this from the observed data. Newton's second law is famously known in the form F equals ma. However, we need to manipulate this to find the form for motion prediction. In our experiment, we are making the assumption that any external forces are balanced and therefore the net force is zero, resulting in constant velocity. Again, we take the equation shown earlier and manipulate it to give us the form we require. And as the net forces are assumed to be zero, we see that the updated velocity is equal to the previous velocity for the given time period. So now to set up the computer model. We are only interested in the areas of the program where the model's parameters are set. Here we've set the ball's mass to 3 grams or 0.003 kilograms. We set the initial ball position to 0, shown earlier, and the initial velocity, again shown earlier. Then the start time t0 is set here. Here we set the time interval, or delta t, to 0.01 for good resolution. And now we come to the area of the program where the calculations are performed. If we looked back to the observation data, we would see that the last data point was 0.466, so we use this as our limit to the calculation process. And here we set F net to 0 as discussed earlier, making the assumption that no net forces are in play. Here's where Newton's equation is written in code format. And here is where the ball's position is updated. And finally, we update the time. The program now performs an iterative loop process for all the data points. And running the program, we see a simulation of the ball movement and a graph being generated. And now to compare the results. Here we see both sets of data plotted on one graph. Both lines are straight and close together, but there is a small discrepancy between them. The observed ball positions appear to be advanced with respect to the model. This was a surprise, as it was expected that external forces would actually slow the ball. One explanation for this might be a systematic measurement error. Thanks for watching.